In this video, we'll be going over the important integral rules that you need to know for integration. So let's get started. If I wanted to integrate a constant, and I'm doing it with respect to a variable, let's say x, then all we would do is we would just add x to the constant, and then we would do plus c. For all of these questions, by the way, there will always be a plus c, and the plus c is pretty much another way of me saying a constant of integration. Constant of integration. So for all of them, for an indefinite integral, you must always do a constant of integration. Now what happens if we have something that looks like this? Something where we have to do x to the power of n, where x is the variable and n is a constant. Well, the integral of this, all we would do is we would add 1 to the power, so n plus 1, and then we would divide by the new power, n plus 1. And so that is how you would integrate something like this, remembering to do the plus c always at the end. Now what about if we have an example like this, where instead of just a variable, we have a function, and that's raised to a power? Well, we could do the similar thing that we did in this equation here, in this example, where we just add 1 to the power and divide by the new power. However, the only difference here is we have to have the derivative of the bracket next to it, like such. If we have the derivative of the function next to it, then we can use the rule from before, and we can say this just becomes f of x to the power of n plus 1 divided by n plus 1. That rule to you might seem a little bit complicated, but let me explain what that actually means. Let's say I'm taking the integral of this function here, 3 dx. Now, I can do this question in multiple ways. I can either expand everything that I have here so I get a polynomial, and then I can use the first rule where we just add 1 to the power and divide by the new power. Or I can do it the easier way. So I'm going to pretend this here is my f of x, and I need the derivative of this inside bracket next to it. And so we know the derivative of the bracket is just 2, so I'm going to put a 2 here. However, I can't just times by 2 just because I feel like it, because that changes the question entirely. The question didn't have a 2, so I can't just introduce a 2 with no reason. So what I'm going to do is I'm going to times by a half on the outside as well. A half times 2 is equal to 1, and they just cancel. So in other words, I could have rewritten this expression without the half and the 2, and they would still be the same. So now that I have it written like this, I can integrate it like I did using the rule. I would just add 1 to the power, so 2x plus 1 to the power of 4, and divide it by the new power. But I have to keep in mind that this 2 is included inside the integral, but the half just remained outside. So I'm going to times this by a half as well, and plus c. Never forget plus c. So then this just becomes 2x plus 1 to the power of 4 divided by 8 plus c. And that's how you would use that second rule to integrate a function raised to a power. Now let's go over our trig integrals. If I wanted to integrate our basic trig functions, like the sine of x, that is just equal to the minus cosine of x plus c. And if you think about it, if you were to differentiate this expression, you should get sine. And from my other video where I go through all the differentiation rules, you should know that the derivative of minus cos is sine. If we were to integrate cosine of x, that is equal to the sine of x plus c. And if we were to integrate the tangent of x, that's equal to minus ln of the absolute value of cosine of x. And you're probably wondering, where the heck did I get this from? I'll explain it in a few minutes' time when we go over a different rule. Now let's have a look at some more trig integrals. Let's say I have an example where I have sine of f of x like this, where it's inside a bracket. Well, it's similar to the third rule I went over, where we needed the derivative of the bracket next to it. So I need to have the derivative of the bracket next to this function, and if I don't, I can introduce it like I showed it to you before. And this is simply equal to minus cosine of f of x plus c. And now what about if I were to do the integral of cosine of f of x? Well, the same rule applies again. I need to have the derivative of the inside brackets. So I need to have an f dash x, and the integral of this simply becomes sine of f of x. Now let's say I want to do some exponential trig. Let's say I want to do the integral of e to the power of some function. Well, the same rule applies as before. It's pretty similar to all the other rules. You just need to have the derivative of the power next to this function, and voila, it's just e to the power of f of x plus c. Now, what happens if we have an integral where we have the derivative divided by the original function? What can we differentiate to get this? Well, we can do ln. We can do the ln of the absolute value of f of x and do plus c. Because if we differentiate this, we will just end up back here. Now remember when before I was talking about the integral of tan of x was equal to the minus ln of the absolute of cosine of x plus c. And you're probably thinking where I pulled this out of and how this integral is even equal to negative ln. Well, this is how I would derive the formula. If I were to rewrite this integral as the integral of sine of x divided by cosine of x, they would still be the same thing, because tangent can be rewritten as sine divided by cos. Now that I have this, I can do one very sneaky thing. I can include a negative in the outside, where I've rewritten it as sine over cos still, but I can't just introduce a minus just because I feel like it. So what I actually have to do is I have to include a negative inside the brackets as well, because negative times a negative will just cancel. And so I'll choose to have the negative on the top here like this. Now what you notice is the derivative of the denominator is on the numerator. And if you recall from one of my rules, if the derivative of the bottom is on the top, we would just make this ln, we would make this natural log. So that's why I can just do the ln absolute value of the cosine of x plus c. But remembering to put the negative on the outside, that is where the integral of tangent is equal to ln. Now let's go over some inverse trig examples. Let's say I wanted to integrate an example like this, a squared minus x squared dx. Well, the integral of this simply becomes this inverse sine, a times the inverse sine of x over a plus c. I'll make another video on how to derive this, but for now just write this down and note it to memory. If I have the integral of minus a divided by the square root of a squared take x squared, that's equal to the a times the cosine inverse of x over a plus c. And lastly, if I have the integral of a divided by a squared plus x squared, that's equal to the inverse tan, a times the inverse tan of x over a plus c. Again, I'll go on how to derive this in another video, but these are all the rules that you need to be aware of for now. This is part 1. So thank you for enjoying, and if you enjoyed this video, please make sure to like and subscribe and leave a comment if you would like me to go through a specific topic or if you have any questions regarding the info and the content. Thank you.